assume that something is dependent of something, you assume that everything is dependent.
Okay.
So here somebody gives us this table and says everything is dependent implicitly.
All right.
And we are saying that it's enough. We don't really care about independent or not. So that's the answer to the question. So nobody has told us that something is independent of something. We assume that everything is dependent. So the advantage of saying something is independent of something is then one need not give this full 2 power n table. That's what we go next to Bayes networks.
So you would need a table of 2 power n if there was independence
Yes.
of all variables. Okay.
And when we say that two things are independent, do we actually make all those columns in the full distribution table zero? I mean, could we
No,
compute
the
that?
way we represent is different. So now we go to Bayes network. Now, yeah. So how does a Bayes network look like?
What's the given Bayes network? What's the given Bayes network?
Yeah, I'll just draw it.
Oh, you're gonna write.
I didn't have the time to do this. So we have 3 variables, right? I will draw a 3 variable Bayes network. First is A, and then is B, and then is C. Normally we saw that, in a full joint distribution we need 2 power 3 minus 1 probabilities. Okay. Now I have more information here. What this Bayes network tells me is that this is independent of C given A.
Wait, can you say that last part again?
Probability of B is only dependent on A. It's not dependent on C. Similarly, probability of C is independent of B given A. Okay? So then I don't need 2 power 3 minus 1 probabilities to solve any problem, any query on this. Okay? If this information is given that B is independent of C given A and C is independent of B given A, then I just need to say what is the probability that P of A is true and P of A is false. Okay? Which means somebody should just tell me what is the probability of A. I can automatically get A being false 1 minus, right? Similarly, somebody just needs to tell me what is the probability of B given A and what is the probability of B given not A. When A is happening, what is the probability? When A is not happening, what is it? Okay. Here C doesn't come into the picture because we know that whether B can or cannot happen is independent of C given A. Okay, this is all the information we need. Similarly here, all we need is this and this. Right? So we can answer any query just like we did with full joint distribution with just these 5 values. Right? This is 7 earlier.
Why is it 7? Why is it 8?
Because
So 2
okay, so basically the sum of all cases is 1. So if one of them is missing, we can easily get it. Sum the rest and 1 minus that will be.
Yeah, I think it has a name in math, right? Isn't there a name for this? No, I think it's different. When you can use less information, because you can derive some. Doesn't this have a name in statistics or math?
This is a normal equation solving. I mean, you have n variables.
I don't.
and,
I'm not getting it right.
And n minus 1 have values. So
Yeah,
is this not?
but I thought it was a concept.
Maybe there must be similar concepts.
Yeah.
So yeah, basically giving this extra information which is represented in terms of this network, we are getting away with less probability numbers. And we will still be able to answer any queries like we did before. Like, for example, we can do all these things. We can go back and do all these things.
So I have a little question. So given a Bayesian network and only these 5 probabilities, are we also intending to say that we can infer a full joint distribution?
Yes, you can actually, given this, that is actually my first task in this. Yeah, construct full joint distribution.
Okay.
You can actually get that using this information.
You
This
get the same
network
data.
and this file. Yeah, if appropriately, if that is actually the case. That I have randomly generated. So right now, if I randomly choose these things, it may not match that. Right? If I just pick whatever comes to my mind, it may not match that.
You will still get there, right?
Yeah, but we'll still be able to generate the full distribution.
So, okay, but the generated distribution will have the same probability values that in the table?
No, because I am randomly choosing it.
Okay. But it's helpful even though we pick them random because we can compute the...
Yeah. Basically,
The
the
relation.
point is that with less amount of bytes or numbers, you will be able to answer the full range of queries which, a full joint distribution can answer. Whatever this table can answer, we'll be able to answer with this information.
But the advantage is one that we use less information, right?
Yeah, this is much less in size. So imagine, so yeah, that's an exercise. I have put up a problem statement. Yeah. So let us take this case of one more variable, right? Let us say there is d. Okay. Then what is the size of full joint distribution? 2 power 4 minus 1, right? Which is 15. And what is the size of this?
9.
We need basically d when b is true and c is true, b is true, c is not true, b is not true, c is true, and both are not. It is dependent only on b and c. Right? So all we need is 5 plus 4. 9, and this structure is equivalent to 15 in terms of the power of structures. So if you put something else, say E, how much do we want? P, E given T and P, E given not T. So plus 2. 11, you can cover 5 variables. This is the structure. Whereas here you want 2 power 5 minus 1, which is 31. See where we are going?
What about
Same thing.
What about
Put one more.
why not? You don't need when B. You don't for node D. You don't need B given C.
Where
B.
for B?
Yeah, you listed B given not C, right? Or is that B and not C?
So yeah, sorry. So this is all given. Okay.
Oh,
We need
oh,
this
okay.
information.
Oh,
B
I
given.
thought you derived. Okay, my bad. There. Okay.
All these numbers need to be given. Right. So based on the structure, this can be really small. Imagine a structure where we have things like this: A, B, C. It's just linear in terms of the number of variables, right? Size. So yeah, that's a good exercise. So if we have n Boolean variables, A1 to AN, and this is the structure of the network, how many probabilities do we need?
1 plus 2 into n minus
N minus 1.
we need 1.
And then we need
Here
2
we need
into n minus
2, right?
Yes.
And 2, 2, 2, so on to here, right? So A2 given A1, A2 given not A1. Similarly for A3, A3 given A2, A3 given not A2. That's how it is, right? Clear? So how many entries, how many probabilities do we need if this is the Bayesian network?
So 1 plus 2 into n minus 1.
So 1 plus 2 plus so on up to 2, this comes n minus 1 times. So 2 into n minus 1 plus 1, which is 2n minus 1. Linear in n, right? Whereas if we want to solve, ignoring the independence relations we have, basically here we have a lot of information. This says that A3 is independent of A1 given A2. A4 is independent of A1, A2 given A3. So all this information is captured in this simple structure. And so we just need this many probabilities. Whereas if we go that way, then this will blow up 2 power n minus 1. So 2 power n becomes 2n.
That's like a Markov network. It only depends on the previous state.
Yeah. So this is the advantage. So based on the structure, there can really be large amount of gains in terms of the number of probabilities to be specified. So this is all powerful. This is also all powerful. This is a compact way of representing independence relations.
But I think that you said Markov network would include the parents of your child. For the linear case, that would be easy because you would only have one parent. So if you're considering the parent of your child, you're the only guy. But
If you have multiple.
yes, then it would be a little. It would be different from the vision.
Yes. Okay. So I hope basically you got the point why bias networks are useful. Right? And yeah, now let's see if we can build this thing back. Where is it? So let us say now we have this network. Simple A, B, and C. Okay. Now let us say PA is 1.
The difference is why the Bayesian networks are directed and cyclic. And Markov networks are undirected and acyclic.
Okay.
That's the difference. So I guess in a sense the Markov networks are a bit more complicated. Than both sides.
Consider the parents of the other thing. I mean, it's like a sibling parent.
So now we want to find all these properties. So let's, what is PA? This is the first entry of the table, right?
Is this where we use the chaining rule to find?
Yeah. So this is basically the
does break down into P of B given C and D. Shouldn't it be P of B given C and D? Although yes, C is independent.
Yeah. So you can have it.
P of C given.
Okay. So this is basically PABC by PA. I just took PA of the base rule. Then I just separated C out.
It's probability of A and B and C. The first one.
First one is
No, the first one. It's probability of A and B and C.
yeah.
Okay.
A is true, B is true, and C is true. So here's the interesting part. This is from the network, right? We know that this is same as this.
Because it's not right.
That's what we know from this network information.
Probability of
B given A and C is same as B given A because B is independent of C.
So the first two lines were derived from base rule,
Yeah.
and then
This we have used the basenet information. You can also kind of get the same thing directly from here, right? If you know that B and C are independent given A, same as B given A and C given A. If two things are independent, then it's just PB into PC kind of. Right? Same thing. So this value is okay. Any questions? Yeah, if you understood these two steps, I think rest of this is clear, right? BC given A is BCA by PA, and PA we took that side.
wait, where did that come from? The BC given A?
Is from base rule.
That's from base
BCA
rule.
by
Okay.
PA.
Yeah.
PA goes there.
Oh,
And this to this is once again base rule. BC given A is B given AC and PC given A.
If you want to calculate P of A given BC, do we need to construct whole table before calculating those kind of things, or can we do directly?
What do you want to? Yeah. So we'll come there. So right now the question is whether we can really, given this information, is it sufficient to get the full joint distribution? And we know that once we have full joint distribution, we can do anything. That's what we learned in the previous problem.
But what he's asking, I mean, is it necessary for us to calculate?
No. So this is one way, right? The zeroth order way that Rao has taught in the lecture. First, you can easily construct the full joint distribution, and then this is how you can write a program to decode. Of course, you yourself can use base rules on top of this and try to get it.
But then constructing the full joint distribution doesn't make any sense because you would still need that much of space to store the full joint distribution if you want to calculate it. I mean,
Yeah, it doesn't make sense. Yes, just for our understanding that this is actually possible. This uniquely gives us a full joint table. Alright. So is this step clear? Whether how this? So this you can write it as basically. Yes, if you want, you can write it as B given C given A into B C given A. This becomes basically B given C column A. That makes it easy.
I just deduced that, so.
Yeah, so this is basically the way we get here is you can look at it as basically you have this given A, keep it aside, and BC is basically B given C into BC. Alright, and this is same as this. Alright. Any questions? So can you just give me this number, P not A and B not C? Which is basically the center limit. Can you try to get the value of this? So how did I come up with this A? How do I know that I have to take A out first? So it's because A is at the top, and the probability of the things at the top are directly available. So you should make them evidence as early as possible. So I see that given this ABC, I see which of them are at the top and take them out separately. If it was the case that this is B and this is A, I would have done A, C given B and BB. Okay. So how do we do this? Which one to take out? Once again here, right? Because A is at the top. So we'll write it as B not C given not A into P not A.
Wait, where'd you get that from?
Base rule.
That's all.
No, and we can use a different formula also, right? Because we have three variables. Basically,
So
we
which
can
one do
apply
you want to
base
use?
in- But you said because A is on top,
Yeah.
there's only one variation we use.
Yes.
There's one.
Yes. Because this value is directly available.
It's what?
This value is directly available, right? For example, if we write it as this, P, not A, not C given B into PB, then we don't know what PB is, right? We only have information of,
Yeah,
and it
that's-
becomes one more level to calculate PB.
And I think to your question, how we got that
No.
with this is basically we multiplied P
Yeah, no.
probability of not A on the numerator and denominator, and we made this the base rule thing.
Yeah, no. I for some reason I saw, when I first looked at it, I saw not B in the middle
Oh,
and
I
not just big. Yeah, so I was like, where is that? Yeah, that is.
These two terms here, and this just becomes evidence.
Yeah, I mean, because order doesn't matter in conjunction.
Yeah.
So yeah. Okay.
So basically at each, juncture you need to decide what you want to make evidence. And you will make that thing evidence which you can directly infer from here. So because P naught A is something which is directly available, I make naught A as evidence. Okay? Everything right side of this bar is evidence. Clear? Any questions? So yeah, just to rewind, right? What is base view? It's just x1 to xn is, take x1 to xk, xk to xn, xk plus 1 to xn, and into probability of xk plus 1 to xn. Let's not do this. Just do this. Actually, directly. Xn minus 1. If you further break it down, it will result in something else.
What's wrong with the previous? It's all the same thing.
I think it will result in the same result. That product will anyway result in equivalent combination. We just need to verify it. Okay. This is the safest way. This is what we use in all our calculations. So what is this? Once again, the sense of it. Given A, basically B and C are independent. So we'll get so I skipped this extra step.
It's 0.027.
So this can be directly read, 0.3. What's the next one? Not C given not A. It's not there. It's basically 1 minus P C given not A, right? And this is 1 minus P. Is it clear? So now let us try to answer some queries on the website. We know how to answer queries on top of this table, right? We already covered it in the first one. So now let us try to answer some queries on this. Which query do we want to answer?
You need an example from us.
Yeah.
Probability Now, probability of C happening, given that B happens and
Probability of C happening given B happens. Okay. This is the result. So how do we solve it?
Wait, what?
well, first of all, we know that C doesn't depend upon B.
Given
But B depends upon A.
Yeah. So C doesn't depend upon B given A.
When you say given A, do you mean A is supposed to be true, or do you mean given the probability of it? I mean,
Given information about A, whether it's true or false.
okay.
So that's why here, I just care about given A, whether B and C are independent. Whether it's not or not, it doesn't really matter. Whether something is dependent or not. If it's dependent, negative or positive influence. If it's not dependent, doesn't matter whether A is true or false. So how do we solve this?
So do we need to rewrite that because C does not depend upon B?
Yeah. So basically we need to bring in A. That's what we have information, right? We want something to know about C and C is linked to A. So we need to bring in A. So basically how do we bring in A is given this is C given B comma A to be A. If A is happening, right? And if A is not happening, then C given B comma not A. Right? We just need to cover that. And once A is there, you know that this is same as C given A. And all these values will. C A we know, C given not A we know, A and B not A. So actually if you observe, B doesn't matter at all. B gets away. So it's about what is probability that A is happening and A is not happening. This is completely independent of B. Could have many more things here